Look at your hands for a moment. Now think about this. The iron in your blood was forged in the heart of a dying star billions of years ago. The carbon that forms your skin came from cosmic explosions, so violent they released more energy in seconds than our sun will produce in its entire lifetime. The oxygen you're breathing right now was created when the universe was just a few minutes old. You are, literally, made of stardust. But how on earth is that even possible? Welcome back to Cosmic Frontiers, Cosmic Explorers. Today we're going to unravel one of the most epic stories of the universe, how absolutely everything that exists was manufactured from nothing. We'll discover how a universe that started with just hydrogen and helium managed to create all 118 elements of the periodic table, including the rare elements in your phone's processor, the gold in your rings, and even the calcium in your bones. Prepare for a 13.8 billion year journey, from the first few minutes after the Big Bang to the most violent neutron star mergers in the cosmos. And I can guarantee that by the end of this video, you'll never look at the world the same way again. We're on an incredible journey towards 1,000 cosmic explorers. And today you'll understand why we are, literally, a part of the universe trying to understand itself. Our story begins 13.8 billion years ago, when the universe was a mere 20-minute-old baby. Imagine the entire universe compressed into a space smaller than an atom, with temperatures in the trillions of degrees. In this cosmic inferno, something extraordinary was happening. Primordial nucleosynthesis, or as I like to call it, the universe's first chemical factory. Think of the early universe as a cosmic pressure cooker. Just like you cook beans under high pressure and temperature to soften the grains, the universe was cooking protons and neutrons under extreme conditions to form the first atomic nuclei. But there was a catch. This window of opportunity would only last a few minutes. The universe was expanding and cooling rapidly, like a pressure cooker losing steam. During these precious few minutes, protons and neutrons collided with enough energy to stick together, forming deuterium, a heavy version of hydrogen. Next, these deuterium nuclei combined to form helium-4, the second lightest element in the universe. Imagine trillions upon trillions of these collisions happening simultaneously across the cosmos, like a frantic dance of particles creating the first building blocks of reality. But here's the plot twist. After about 20 minutes, the universe cooled so much that this dance abruptly stopped. Primordial nucleosynthesis had created approximately 75% hydrogen and 25% helium, with minuscule traces of lithium and beryllium. And that was it. End of the first phase. For the next 400 million years, the universe was just a dark soup of hydrogen and helium floating in space. No carbon, no oxygen, no iron, zero heavy elements. Now you might be thinking, hold on a minute, how did we get here then? Excellent question. And the answer lies in the stars. Stars are the universe's true alchemists, the factories where simple elements transform into complex ones. Let's use an analogy. Imagine you only have flour and water in your kitchen, but you need to bake a chocolate cake with frosting. Impossible, right? But now imagine your kitchen is magical and can turn flour into sugar, into chocolate, into eggs, into butter. That's exactly the magic that happens in the heart of stars. They take hydrogen and helium and transform them into all other elements. The process is called nuclear fusion, and it happens in the core of stars under conditions that would make primordial nucleosynthesis seem like child's play. We're talking about temperatures of 15 million degrees Celsius and pressures 200 billion times greater than Earth's atmosphere. Under these extreme conditions, hydrogen nuclei fuse to form helium, releasing enough energy to make the star shine for billions of years. But the real magic happens when a star ages. When the hydrogen in its core runs out, the star enters cosmic panic. Imagine a stoker running out of fuel. To keep the fire going, he needs to burn something heavier. The star does exactly that. It starts fusing helium to form carbon and oxygen. When the helium runs out, it fuses carbon to form neon, magnesium, and sodium. It's as if the star is climbing the steps of the periodic table, element by element. Stars like our Sun can reach carbon and oxygen before dying peacefully, transforming into white dwarfs. But massive stars, those with more than 8 times the Sun's mass, are true heavy element factories. They continue fusing increasingly heavier elements. Carbon turns into neon, neon into magnesium, magnesium into silicon, and so on until they reach iron. And here we reach a crucial moment in cosmic history. Iron is like the end of the line for nuclear fusion. Fusing iron doesn't release energy. In fact, it consumes energy. It's like trying to start a bonfire with wet charcoal. It simply doesn't work. When the star's core fills with iron, it's as if it has reached the end of its rope. Fusion stops, gravity wins, and within seconds the core violently collapses. But wait, there are still 26 elements missing from the periodic table. How did the universe create gold, uranium, platinum, and all these super heavy elements? The answer lies in the most violent events in the cosmos: supernova and neutron star mergers. Imagine the following scene. A massive star has just exhausted its nuclear fuel. In less than a second, the star's core, which is the size of Earth, collapses into a sphere just 20 kilometers in diameter. It's as if the entire planet Earth were compressed to the size of the city of São Paulo. The density becomes so absurd that a single teaspoon of this matter would weigh as much as a mountain. This collapse generates a shockwave that travels towards the star's surface at 10% the speed of light. When this shockwave hits the star's outer layers, an explosion so violent occurs that for a few days it shines brighter than an entire galaxy with 100 billion stars. This is a supernova, and it's during this cataclysmic explosion that elements heavier than iron are forged. But we still have another type of cosmic event that manufactures heavy elements: neutron star mergers. Imagine two neutron stars, each with a mass greater than the Sun, but compressed into a 20-kilometer diameter sphere, orbiting each other thousands of times per second. Over time, they lose energy and draw closer and closer, until they finally collide in an explosion called a collision. This collision is so violent that it creates ripples in the very fabric of space-time gravitational waves that scientists first detected in 2015. During this merger, matter is compressed to densities that make the Sun's core look like a vacuum. Under these extreme conditions, super-heavy elements like gold, platinum, and uranium are produced in astronomical quantities. To give you an idea of the scale, a single neutron star merger can produce 200 times Earth's mass in pure gold. All the gold that exists on our planet came from events like these: your grandmother's wedding ring, the gold nuggets found in Brazil, the gold in your smartphone's circuits. All of it was forged in the violent merger of neutron stars that happened even before our solar system existed. Now, let's connect all these dots. For billions of years, generations upon generations of stars lived and died, each enriching the universe with heavier elements. The first stars were made only of hydrogen and helium, but when they died in supernova, they scattered carbon, oxygen, neon, and iron throughout space. These stellar ashes mixed with the interstellar gas and were incorporated into the next generation of stars. It's like a cosmic recipe that gets more complex with each generation. The first generation made the basic ingredients. The second generation added more spices. The third generation created more complex flavors, and so on. Our Sun is a third-generation star, made not only of primordial hydrogen and helium, but also of all the heavy elements created by previous generations of stars. And here's the most incredible part: when our solar system formed 4.6 billion years ago, all these elements were present in the cloud of gas and dust that gave birth to the Sun and the planets. The iron in Earth's core, the carbon that forms the basis of life, the oxygen we breathe, the calcium in our bones, the phosphorus in our DNA. All these elements were created in the heart of stars that died long before Earth even existed. Carl Sagan once said that we are made of stardust, and now you understand that this isn't just poetic metaphor. It's literally true. Every atom in your body, except hydrogen, was forged inside a star or during a supernova explosion. You are the result of 13.8 billion years of cosmic evolution, a collection of elements that traveled through space for eons before finding each other and forming you. Think about it. The carbon in your skin might have come from a star that exploded 8 billion years ago. The iron in your blood could have been created in the heart of a red supergiant 5 billion years ago. The gold in your wedding band might have been born from the violent collision of two neutron stars 6 billion years ago. You are literally a walking museum of the universe's history, and the story continues. Right at this moment, stars are being born and dying in distant galaxies, creating new elements and enriching the cosmos. Supernovae are exploding, scattering heavy elements throughout intergalactic space. Neutron stars are colliding, forging gold and platinum in unimaginable quantities. The universe is a cosmic factory that never stops working. So, the next time you look up at the night sky, remember that you're not just observing distant points of light. You're looking at the factories that created you, at the cosmic blast furnaces that transformed a simple universe of hydrogen and helium into the complex tapestry of elements that makes life possible. You're looking at your cosmic origins. This leads me to a profound reflection. If we are all made of the same stars, if we share the same cosmic origins, does that change our perspective on our place in the universe? Does understanding that we are literally part of the cosmos make us more connected, not just with each other, but with everything that exists? Cosmic explorers, I want to know what you think. In the comments, tell me, which element of the periodic table do you find most fascinating and why? And since we're talking about cosmic origins, what mystery of the universe do you want me to talk about in the next video? Leave your suggestions in the comments. I love discovering what sparks your curiosity. We're on an incredible journey towards 1,000 cosmic explorers. If this video sparked your curiosity about the universe and made you feel more connected to the cosmos, join our crew by clicking subscribe. Like this video if it expanded your cosmic horizons, and share it with someone else who also loves the mysteries of the universe. In the next video, we'll explore another fascinating phenomenon of the cosmos. So turn on notifications so you don't miss any discoveries. Keep exploring, keep questioning, and remember, you are the universe contemplating itself. Until the next cosmic adventure.